Now we're going to focus on how to read the micrometer. Now micrometer has a range of 0 to about 25 mm. It can measure within this range. It's small, but it can measure very small division of 0.01 mm. Now take note that the vernier caliper not so accurate. Vernier caliper only up to 0.01 cm, whereas micrometer can be up to smallest division of 0.01 mm. Now, this is the main scale of a micrometer. So this is 0, 1, 2, 3, and so on until 25. Now, this is in mm. Now, the one below, which is not marked, is obviously 0.5. Alright. And then this one will be 1.5 and then 2.5. So now on the other side, there is a timber which is actually cylindrical like this. It actually can rotate like this. Alright, but for exam question it come out as if it's flat. So let's learn how to read. Now this one, the scale is of this timber is about exactly 0 to 50, but for illustration purpose we use 15 to 20. Alright, now suppose it is here, okay, here. Now can you see this line here? Now so it's between 0 and 0.5 mm, but this line, the main line coincide is 16. So in this example is 0.16 mm. So 0.16 mm. Alright, let's look at another example. Let's say is this way. Alright, so now this time round the main line coincides 17. Now we must be careful not to say that it's 0.17 mm. The reason because 0.5 is already out already, so it's actually 0.5 and then add on to 0.17, so it's actually 0.5 add on to 0.17 is actually 0.67 mm. Sorry. So in this case this is 0.67. Now let's look at one more example. Okay, let's say this one. Okay, now in this case this is 1 point something, right? Alright, 1 point something is 1.21 mm. Okay, 1.21 mm. So if you rotate down it will be 1.22. Now however if it's like this, alright, if it's like this, then we must be careful that because 1.5 is out already, so this is actually 1.5 plus 0.18, which is 1.68 mm. So it's 1.5 plus 0.18, so it's 1.68 mm. Alright, so this is 1.68 mm. So for micrometer is rather simple, except that if the 0.5 has come out, we must be careful not just simply to read the numbers here, you must add on to the 0.5. Okay, now let's go on to the zero error. Now zero error, like vernier caliper, if the jaws are closed and if it's a new and accurate machine, there should be no zero error. So the 0 point is supposed to coincide exactly like this. However, if there is a positive zero error due to wear and tear, example like this, then can you see the gap between here and here? Okay, it's a small gap. So in this case, the zero error is 0.02 mm. So we say that it's a positive 0.02 mm. So whatever reading that you take later must minus 0.02 mm. Alright, it's like the vernier caliper. Now this is a positive zero error. Another example will be 0.03 mm and so on, 0.04 mm. Now what about negative zero error? Now instead of rotating clockwise, okay, if it's below here, okay, below will be you go beyond this way, all right. So if this is a zero line, you go behind it, we can't see anymore. Then we say that the negative zero error, because one coincide, is minus 0.01 mm, and whatever reading we take later, we must add 0.01 mm. So if the zero error is this way, all right, then it's a negative 0.02 mm. All right, thank you for watching. You may need to replay the video in order to fully understand. Thank you.